So this session right here today, it's about breaking silos. We are a tax technology and transformation group at EY, and so we work specifically within financial services. And so, there are a lot of different silos of data within organizations, right? And one of the interesting things about tax is that we actually need data from all across the organization. And so, how do we break down these walls between our clients' organizations so that we can bring this data together and get value out of it, not only from a tax compliance perspective, but also just from an analytics and insight perspective as well. So this is the team here today. Coskun is on the line. He leads our entire tax technology transformation practice called TTT within financial services. I'm Michael, and then Han and Jack are also here as well. We're very focused on kind of the data and AI aspect of TTT. All right, so today's agenda, we're going to start out just talking about fragmented data. Basically kind of lay out the landscape and some of the problem statement that we really deal with within our practice and within our the specific clients that we serve. We'll go into kind of the graph itself and some of the things that we think about as we try to build the graph out. We'll demo a little bit on how we move data from our data warehouse into Neo4j, some of the things that we think about, and then finally the kind of takeaways and talk about what's next for our product. So without further ado, we'll jump in. All right, so as I mentioned, within tax, it's very interesting problem statement because we really get information and data from all over our clients' organization. Given that our clients are mostly within financial services, they have investors that invest in funds. They have legal entities that are put together in very complex structures. They do deals with other parties. And so the data from the deals is really important. The financial data and accounting data from the organization itself as well. And then also just, information from legal documents, partnership agreements, side letters, a lot of different legal documents where the information on them is actually really relevant to, how our teams do their tax work and what kind of filings they're required to do. And so, one of the challenges is, within our clients, there's data all over the place, different technologies, different platforms, and each part of the organization, each business unit, they're really responsible for that data and they really use it, for their specific purpose, right? But tax, as a kind of one of the final consumers of that data, we need to really bring all of that together and in a way that we can, do the tax compliance work and do the correct filings and also provide to the investors the information they need for their own purposes as well. Here's just a picture of some of the common kind of platforms and systems that we have to get data from. This Excel symbol is like just this one picture on here, but so much data we get is just stored in Excel, and depending on the client, it might be the database for certain data sets, and so we have to figure out how to deal with all of it, right? So the way we approach it is, we build a common data model. Basically, we want to bring all this information together into a tax data warehouse, right? We need to relate data from a financial system or from an accounting system to like the legal entity or to the investor, right? And so it's really helpful for us to have kind of a one data model that's designed for tax, for financial service clients, where we really understand all the different data points that are in there, why we need it, what processes they drive downstream. And so, we have a data warehouse, and we're using Snowflake for most of our clients. And basically, we have pipelines and processes in place to make sure that the data in our data warehouse is high quality, right? We have automated data pipelines. We have automated kind of data quality reporting, feedback loops to our clients or maybe to their third parties. Basically, we want to make sure that our data warehouse has really high quality data and it's really well defined within the common data model because it feeds so many different processes downstream. For example, most of that data, one of the primary uses of that data is just to feed tax compliance processes, right? We're filing returns in different jurisdictions, not only in the U.S. and the different states, but also across the globe. But also for tax analytics, right? Our clients will come to us and want to know that the way they structure their entities is giving them the tax outcomes that they want. And so we do a lot of analytics as well. But the tax data warehouse that we created is super valuable to all these processes. But there's a little piece that's missing that is harder to get out of a traditional kind of SQL-based structure, and which is relationships, right? Within financial services specifically, these entity structures that our clients have are, one, very complex, two, across the globe, right? They'll have entities within the U.S., all different countries. They'll have investors within the U.S. and all different countries, and the investors themselves have different attributes that impact, how they're taxed, right? They might be tax exempt. They might be in a country that has a treaty with the U.S., and so their withholding rates different. So there's all this information across the entire kind of complex structure, and so it's all in the tables within Snowflake. But in order for us to really kind of reason about it and really understand it, it's helpful to put it into the graph structure. And so, here you just kind of talk a little bit about, some of the business impact. The relationships really matter, as I mentioned, right? I had some examples on the previous session, but basically, from the lowest level entity, legal entity, I would say, within a structure, it would be an entity that invests in, one property or one asset, right? And so that's the very bottom. And then it flows all the way up ultimately to the investor who's in a fund, or even above them into the kind of management company of our entire client. And then they have employees who have shares and stuff as well, right? And so the hops from that bottom investment all the way to the top could be 15, 16 hops, right? And every single hop, every single node that it passes through has some impact on the tax liability or tax outcomes. From a technical perspective, I think this is this is nodes. So everyone here probably really deeply understands kind of the value of having a graph and being able to traverse all these multiple hops without having to do all these recursive queries.
Yeah, and one of the other problems that we face, as Mike is to like explaining, this is your traditional networking problem, right? Data structures and algorithms, but every single one of those connection points for us is a tax liability, and it's a financial liability, right? And then the next thing that you need to understand is, let's say that something changes, an allocation percentage changes on one of the nodes. You really have to quickly find what are all the nodes that are getting affected by that change. And you really don't want to calculate 150,000 nodes from scratch every time some new change happens in one of the nodes. So just imagine the complexity of the math calculations that you're doing, but really you need to find that the least amount of data that you need to get to quickly and fast to make a decision and make the changes, and then quickly make the calculations. So having this type of a model in one central database is one thing, but having all the relationships is what really matters, because you need to know how to define the problem statement as you're finding this network problem, and then you're fixing it. So to all of you data people, right? It's a data structures and algorithms 101, but for finance people, it's allocating revenue income across all these investors. So same thing, just said a different way.
Yep. Han will talk a little bit about like the kind of the overall architecture that we have. We have data warehouse and a lot of processes in place to make sure it's clean, and then how it kind of flows through to the right.
Yep. Hi everyone. I'm in the same room, so I will just speak from his speaker, right? So this is our blueprint when we are approaching a client to kind of help them build this graph layer for breaking silos, right? I think from the left side, a lot of companies are already doing that, right? They get the data from different data sources, ingest them, cleanse them, put them in a data warehouse. What I really want to focus on this session is from that warehouse to this graph layer, right? We call it, Max said we call the warehouse common data model. We also have a name for this graph, right? Common data ontology. So we are moving. I think our team is one of the few that's actually doing this for a lot of financial service clients. We're getting their data from their warehouse, be it Microsoft Fabric or Snowflake or Databricks, right? So we analyze those, we extract them and build a model and then put them into this common data ontology inside Neo4j, right? With that, if you just zoom in and look at this common data model chart, we have 8 tables. This is just an example, right? So entities. If you work in a company, you know there are thousands of softwares you need to deal with, right? So every software has an entity table. So because entity is a foundation piece for every enterprise, but there could be typos, right? There's entity A's name could be font ABC, but in another software it could be entity ABC. I mean, it could be CDE, right? So but in reality, they're actually one entity. So we don't want to file 2 tax returns for this entity, right? It will double pay the taxes. So what we do with this common data ontology in Neo4j is we kind of analyze their relationships across the data landscape, right? I mean, then we probably already heard about it. The solution is called entity resolution, right? So instead of using some Python libraries just to look at the data itself, we use Neo4j to look at the relationship across different databases. And then we'll find out, okay, these 2 entities are actually having 99% similarity in terms of relationship with other data. Then that probably means, okay, these 2 entities are the same entity, right? So we use this finding and backfill the common data model, right? We kind of fix the issues that the silo systems created. Even you have one single data warehouse, you still have those issues if you don't fix them, right? So that's how we kind of help break the silos with Neo4j, and also everybody's doing ChatGPT or LLM. And if you have done any text to SQL translation, right? If you ever try to ask a question about your database, first, it's not that accurate. Second, is like it has this limitation. You probably can only build an agent on top of, let's say, 10 tables. That's basically it. You can't have like, okay, warehouse, I have 300 tables. I want to build an agent and ask question about it. That's not possible. So, but what we found out is if we use Neo4j, if we build a model on top of this common data ontology, right? It's no longer 300 tables. It's actually just nodes and relationships. Now you ask the question, the LLM knows, okay, I just need to deal with nodes and relationships. It's so easy. I can translate it, and then you put it back into, and then you put the query back into warehouse. You get your answers. So another use case that we found out that we work with the clients, we actually can enrich the feature engineering, because before, I mean, the features are limited. You look at your data, you have those features, you build the feature engineering, you train your models, but still it kind of losing the hidden connections from those siloed databases. So what this Neo4j can bring to the table in terms of machine learning is it can provide additional layer, additional features that you can train your machine, you can train a model on, and we found out that the performance is very good. So that's pretty much.
Yeah. I would say the graph itself, right, is a much better representation of kind of our client's entire business than a bunch of tables with some keys to relate it together. I think the graph kind of puts the really important pieces of the company as a forefront, which is how are things related to each other and what do those relationships mean.
Yeah, I
So
mean, I think it also helps us with pick anomalies, and you'll see Jack with the demo later. But like, when you start thinking about data quality, really what we're trying to find out is like, people oftentimes are fixated on things like, hey, is the legal entity name right? But I don't know if you caught what Hans said was, well, that would mean you're going to file 2 tax returns and you pay money for that. Why would you want to do that if there's only one company? And so having a different letter just makes it look like there's 2 companies, right? So like there's implications of that. But then there's other things, like when we start looking at this data, say for state and local taxes purposes, maybe there's a sales and use tax, and you'll see that this company has never bought paper from Texas. They've always bought paper from maybe Illinois, right? And there's that one node that's sitting there in Texas. And you're like, what is this? It's like you can quickly see we call it at a glance insights. Immediately I can see something's wrong with like if I have a big hub and I say, here's all my sales and use tax, it's all under one state. That's accurate because that's how they design things. That's how they design their legal entities. They design everything with a purpose. You should never have income from a different jurisdiction if you have so many investors from that kind of a jurisdiction. It's by design. You shouldn't. And when you start seeing these little circles, you're like popping up. You're like, whoa, there's something wrong here. And the business people, at a glance, are now translating to insights, which is really breaking those silos, taking it to the insights. That's really what this graph thing is all about. So I'll turn it over to you guys, Han and Jack, as we're about like 10, 11 minutes. So maybe we can move along to the next slide.
Yeah, do you want to go on next time? We can just go off your slides and I'm just gonna share my screen.
I will mute myself.
I got it.
I don't think we can hear you, Jack.
Sorry about that. Can you guys hear me now?
Yes.
Okay, great. So as my teammates here, mentioned, the entire point of this solution is we would like to, take complex data from traditional data warehouses and move them into a Neo4j graph database, right? And when we built and deployed the solution in the client's environment, we had to follow very strict, rules. There's regulations. So essentially, we couldn't just transport that, directly here. However, we did provide a simplified illustration on how we went about building that solution. So long story short, is a 2-phase approach, right? So first phase, we took out all the nodes, right? So imagine the entities and all the attributes that are tied to the entities. We take those out, we extract those from the traditional data warehouse, and then we load them into Neo4j. Second phase is we take the relationships that are between those entities, those nodes, and then we also load them into Neo4j. So what you see on this slide here is a very simplified version. So basically, for the nodes phase, the key properties were entity name and entity type name, and then the labels were just one label entity, and we had a unique ID by entity code. And for the second phase, we only included the owns relationship, and then we also included the specific percentage that a particular entity owned the other entity. So if we move to the next slide. So here is a example. At the top left corner, we have the original data warehouse. So this is a Snowflake table, a very simple table that contains all the entity key information. And then the lower two snippets are the actual codes that we use to both connect to the Snowflake table and then pull out the entity information, do the transformation, and then also load that information into Neo4j. If we go to the next slide. And here we're at phase 2. Similar approach here is we extract the relationships from Snowflake table, we do the transformation, and then we load all that information into Neo4j. What I would say here is we did this particular example using 2 separate tables. However, you could do all this for the same table. And that's what we actually did in the client solution.
And before Jack continues, I mean, this relationship phase of it is really important, right? Because, there's the baseline relationship between legal entities or even a fund and investors is like the owns relationship, right? This legal entity owns another legal entity, or this investor being a partner within a fund, owns a piece of the fund. But one of the powerful things about the graph and the flexibility of it is you can add different kinds of relationships as well, right? And so we have, this whole graph of all these different nodes that represent all the different legal entities, the deals that our clients are doing, the investors they have, and you can have relationships that are not just owns, but it could be like voting share or kind of for at the top level maybe incentive structure, right? They get certain points, like the fund does well, then certain people will get incentivized for managing the fund well and making a lot of money, and so they'll get some percentage of that value. And so this is one of the very valuable things of this kind of structure is you don't have to now go in and create a new schema or anything, right? You just add a new kind of relationship, or maybe you add an attribute to an existing relationship. As we get more data from our clients, they're trying to do different things, and they provide us data that we haven't had before, and we're just kind of add it into the graph and get value out of it right away.
Yeah. Could go to the next slide. Cool. So here, as part of the client solution, we also provided formatting. So for example, specific colors for the nodes, specific font size, things like that. So we can do all that directly within the code itself. And then last piece, and this is the breaking silos phase. If we go to the next slide. So, let's just say one tax team has completed their review, right? Like their data has now been completely moved from their traditional data warehouse into Neo4j database, right? So now, a separate tax team or a separate, finance team, needs to go into the same data to add additional features, additional attributes to it, to Han's point, the feature engineering part, right? So what teams could do is, the exact same approach, right? Like we extract the new attributes from the traditional Snowflake table, we do the transformations, and then we push into Neo4j. We only pull and push the change pieces, and then we use a real-time trigger that will monitor for any changes in the Snowflake table in order to make that push. So there wouldn't be any redundancies. You wouldn't have to rewrite, your entire database completely whenever there's a change. Is truly incremental, and then it's truly monitored in real time.
All right. We only have a few minutes left. I mean, the demo that Jack was going to show, he kind of went over basically the different steps in it. It was kind of be able to see it run I don't know if we really have time to run through
probably
it.
Not.
I mean, it's basically like what he just talked about. You kind of see the data moving from Snowflake into Neo, and then kind of going in and seeing a change. But I think it's.
I think the biggest thing there was the event-based trigger for me as a business leader. One of the things is like trying to figure out over the years, how do we keep this database up to date? We get these big files from clients. We run them quarterly, monthly. We always talk about frequencies. How fast do we get it? How often do we get it? Who owns the data? I mean, now with technologies, being able to stream data, having, triggers and event-based triggers, and making sure that we're almost near real time into the data change and immediately getting in front of the business to make these decisions, I think is one of the top things that I appreciate as a business person on this design. And obviously, for those of you who, software engineers, the part of the engineering side is also really nice on how they're getting these contextual relationships into the data and being able to allow the users to talk to the data. But with that, I'll again turn it over to you, Mike, as we wrap it up.
Yeah, just a few things to kind of highlight here at the end, right? Visualizations are really powerful. Even the kind of like, you get the data into a graph and you're able to go into Bloom and you're able to kind of explore it right there. That's a really powerful way to get buy-in from stakeholders, get them to really understand the benefit of a graph. And so, we definitely use this a lot when we have initial conversations. I'm really trying to understand, kind of the problems that we're trying to solve with this. The kind of framework that Jack described, right? That pipeline really we can use for all kinds of data, within our data warehouse. Basically, depending on the client, depending what they're trying to get out of it, depending on what services we provide to them, we'll have different levels of data to do that. And so as we, get more and more information, we're able to provide more and more value and kind of use that same ETL pipeline. And, if you think about data like from an end-to-end perspective, right, it's going from the client or from third parties through our data warehouse, through Snowflake. And so we have automated data flows there. And this is just like one more step to run to get some additional value and insights out of the graph itself. Real quickly, just some of the things that we learned, some of the things that really helped, drive stakeholder approval of this and then excitement about this, right? Being able to trust the data in the Snowflake, based on all of the kind of data warehouse quality controls we have around it, governance controls we have around it, is really what allows us to move quickly from there into the graph, right? Because we can trust the data in the warehouse, and now we don't have to worry about trying to make sure that we trust the data in the graph as well. It's just the trust kind of flows through. The last point here, I think this common data model is really the foundation. It feeds the graph, but it also feeds many other processes, and having that kind of standardized approach is really helpful. So I think we're out of time. I really appreciate everyone who joined, and if anyone of you joined for both of them, doubly thank you very much. Here's our contact information if you have any questions or want to reach out about anything. So yeah, thanks everyone.